Section 6.4, values of the trigonometric functions. So you'll remember at the beginning of section 6.3, I had mentioned that you were only going to actually need to remember the trig function values in the first quadrant. And actually, because all of the trig functions are based off of sine and cosine, you really only need to remember that the sine is the y and the cosine is the x value, and you really only need to remember that first quadrant functions. So initially I'm going to write down, I guess, the book definition of a reference angle, and then we will talk about what that means. All right, so there is the book definition, if you will. If theta is a non-quadrantal angle in standard position, the reference angle is the acute angle we denote with theta sub r that the terminal side makes with the x-axis. So I have the examples of three obtuse angles, because remember, an angle in the first quadrant would be an acute angle, so an angle in the first quadrant doesn't have or doesn't need a reference angle. Well, if we look at these three angles, if this is my angle theta, then the acute angle that angle makes with the x-axis, this would be my theta sub r. That would be my reference angle. So in other words, it's basically 180 degrees minus whatever that angle is going to give me my reference angle. In this case, this is my angle theta, but again, it's what's the acute angle that it makes with the x-axis. My x-axis is the horizontal. This is going to be my angle theta sub r, my reference angle. And so if you note from this one, I go to 180 degrees, and then how much farther past 180 degrees do I go? That would be my reference angle. And for the third one, I've come all the way around to the fourth quadrant, and so how far is it from my angle to get all the way up to 360 degrees, or we're actually going to be working in radians more frequently, so how far do I need to go to get to a full circle, which is 2 pi? Now this leads us to our theorem on reference angles. So again, I'm going to give you the book definition of this, and then we'll talk about what this actually means. So our book definition, if theta is a non-quadrantal angle in standard position, then find the value of the trig function for the reference angle, and then determine the appropriate sign. So remember, I just want to go over again, a non-quadrantal angle simply means that it's not going to lie, the terminal side will not lie on one of the x or y axes. So this means that if we're going to be using our reference angles, all of our reference angles are acute angles. We really only need to remember the trig functions in our first quadrant, because that's where all of our angles are going to be those acute angles. Remember, determining the appropriate sign is what we spent some time in section 6.2 going over. If one trig function was positive, one trig function was negative, where do both of those occur? So we've spent some time going over determining what quadrant or what the signs of these trig functions should be. Now you're very familiar, usually, most of you, with angles, degree measures. This is going to be degree, 0 degrees. This is 90 degrees. You're very familiar with that. Halfway between those, obviously, should be 45 degrees. And if we cut that 90 degrees in thirds, then this is going to be 30 degrees, and this is going to be 60 degrees. Transferring that to radians. Try not to use the conversion from degrees to radians. You're going to be wasting a lot of time, and radians really aren't that difficult. This is still going to be 0 radians. Remember that halfway across the circle is 1 pi, because all the way around is 2 pi. So now if we think in terms of if this is 1 pi, if we go half that distance, we're going to have 1/2 pi, which instead we usually write as pi over 2. And then 1/2, what's half? Again, this middle one, what's half of a half is 1/4. So we have pi over 4. And now we're going to break this into thirds. So if we break a half into thirds, we have 1/6 pi, or pi over 6. Here we would have 2/6 pi. 2/6 is 1/3, so pi over 3. And then we have 3/6 pi, which 3/6 is 1/2. So there we have our radian measures of all those angles. Finally, tangent, similar to the sine function, all of the answers from a calculator are going to be between negative pi over 2 and pi over 2. And again, that's because the tangent function is periodic. there's going to be asymptotes at negative pi over 2, or actually every pi over 2, because the tangent function is sine over cosine, and cosine has a value of 0 at pi over 2. So since my denominator would be 0, there would be asymptotes at every pi over 2. Now let's do a bunch of examples. First of all, I want you to go ahead and pause the video and draw a 315-degree angle. Where would that be? So a 315-degree angle is, if you think about this, it's 45 degrees away from being a complete circle. So we've just actually answered two questions. How far away is that from the x-axis? I just need to go that little bit farther for my theta sub r. How far off of the x-axis is that? Is 45 degrees. So that's my reference angle. Again, pause the video. Draw a negative 240-degree angle. Again, determining how to draw that negative 240-degree angle can also answer our question as to our reference angle. So we're going in the negative direction, so we have to go clockwise. First of all, I have to go all the way to 180 degrees, and then how much farther into this quadrant do I need to go to get to 240 degrees? Well, 180 plus 60 is going to be 240, so that's my negative 240-degree angle. And my reference angle, how far is that from the x-axis? How far beyond the x-axis did I go? 60 degrees would be my reference angle. Once again, please pause the video and draw your angle of 5 pi over 6. Well, again, determining how to draw 5 pi over 6 can help us determine what our reference angle. So remember that halfway around the circle is going to be pi. So 1 full pi is the same as 6 pi over 6. We have to go to 5 pi over 6. So how much farther would we need to go from our angle, theta, to get to pi? So our reference angle is just pi over 6. The next one's slightly trickier. There's no pi and there's no degree sign. So this is radians. Where would 4 radians be? And a hint, don't forget that pi is 3.14. So where would that angle be? Just a little bit beyond halfway is going to be our pi. So our reference angle, how far beyond the x-axis did we go? That's our reference angle. How would we find that? Well, we've gone beyond it, so we're going to take 4 minus pi. And because we want exact angles, we're just going to leave that as 4 minus pi. We have 2 more in radian mode, so I want you to again pause the video and draw the angle of 7 pi over 4. Again, if you start thinking in terms of fractions, all the way around the circle is 2 pi, but we're dealing with fourths, so 2 pi is the same as 8 pi over 4, correct? But we're only going 7 pi over 4. So again, how far do we need to go to get up to the x-axis? Well, our theta sub r is simply going to be pi over 4. Once again, please pause the video and draw negative 3 pi over 4. On this one, don't forget we have to move in the negative direction, which is the clockwise direction. And again, if we just think in terms of fractions, we have 1/4 pi, 2/4 pi. This is going to be our 3/4 pi. How far do we need to go to get up to a whole pi? Our reference angle, theta sub r, is pi over 4. Now let's use reference angles to find the exact values of our sine, cosine, and tangent. So if we're given 5 pi over 6, well, let's just take a look up above. Number 1c, we had theta was 5 pi over 6, and we found that our reference angle was pi over 6. So let's determine what's the sine of 5 pi over 6, the cosine of 5 pi over 6, and the tangent of 5 pi over 6. So remember, we're just going to use our reference angle. So what is the sine of pi over 6? The sine of pi over 6 is 1/2. And the cosine of pi over 6 is the square root of 3 over 2. And the tangent of pi over 6 is the square root of 3 over 3. Now we have to determine whether these are positive or negative. Again, if you look up at example 1c, that's how we can determine the sine. 5 pi over 6 is in the second quadrant. So in the second quadrant, the sign is positive because it's the y-coordinate. In the second quadrant, the cosine is negative, and the tangent is the sine over cosine. So a positive over a negative means we're going to end up with a negative angle, or a negative value, I mean. Anyway, these come from the fact that our angle is in quadrant 2. For 2b, again, we can conveniently look up above at 1e, and we see that our reference angle for 7 pi over 4 is pi over 4. So now I want you to pause the video and see if you can figure out what the sine, cosine, and tangent should be for 7 pi over 4. So thinking about our reference angles of pi over 4, the sine is square root of 2 over 2, cosine is square root of 2 over 2, and tangent is 1. But 7 pi over 4 is in the fourth quadrant. Below the x-axis, that means the sine is going to be negative, the cosine is going to be positive, but the tangent, which is sine over cosine, is going to be negative. So again, these come from the fact that we're looking at quadrant 4. So 3a, we're going to look at a couple ways. First of all, the sine is 1/2 at pi over 6, but the sine is negative in the third and fourth quadrants. So this is basically my negative pi over 6, but I need to go all the way around the circle, which means this is going to be 11 pi over 6, because another pi over 6 would get me to a full circle. And the sine of pi plus pi over 6 is going to be 7 pi over 6. And again, if you were to put those into your calculator, you would see that you would get a value of negative 1/2. I'd like you to go ahead and try to apply the same process for b. Again, the cosine is 1/2 at pi over 3, but the cosine is negative in the second and third quadrants. So if this is 1 pi over 3, then at the cosine of 2 pi over 3, 3 pi over 3 would be a whole pi, which means this one is going to be the cosine of 4 pi over 3, is going to give me negative 1/2. I'm going to have you go back and do 3c after we talk about and go through number 4 and 5. So number 4, the tangent of theta is that value. To undo the tangent, we're going to have to use our calculator on this. So to undo the tangent, we're going to take the inverse tangent. And remember, if you take the inverse of one side, or whatever you do to one side, you have to do to the other side. So we're going to write this. The tangent and the untangent undo each other, so we get theta equals, and then you're going to put that into your calculator and tell me what your calculator gives you. Making sure your calculator is in degree mode, because this problem is asking us to find it to the nearest degree, we get theta is negative 24.811. Wants it to the nearest tenth, so we're going to do negative 24.8. Now the tangent, we've got a negative value. Where is the tangent negative? The tangent's going to be negative there and there. And negative 24 degrees is not in my interval from 0 to 360. So what we have to figure out is negative 24 degrees, how far off of, for this case, how far before 360 degrees is it? In this case, how far before 180 degrees is it? So go ahead and figure out what those values are. And so the two angles we get are 155.2 degrees and 335.2 degrees. And you could confirm this by putting the tangent of those degrees into your calculator, and you should get that value. Now let's go ahead and try to do the same thing with number 5, the cosine that it's giving us, but now our calculator needs to be in radians. Taking the inverse cosine of both sides to undo the cosine, we end up with theta equals 1.9651. So that's a good answer. That's between 0 and 2 pi. But now let's look where the cosine is negative. The cosine is going to be negative in the second and third quadrants. This angle falls in the second quadrant, so we're good there. But now we have to find our other angle. Our other angle needs to be in the third quadrant. We're going to need to know what this reference angle is. So 1.9561 is how far off of pi. That's going to be our reference angle. So I found my reference angle was 1.1765. Remember, my angle is pi plus whatever that reference angle is, so my other angle is that. I'm running out of time, so I want you to pause the video and write down all 3 of those reference angles. I hope these are the 3 reference angles you found. Please make sure you come to class. We're going to go over some tips and tricks for remembering the unit circle. See you then.